How can we build an AI that is beneficial for everyone? Or we might say an AI that is generally beneficial, a BGI, an AI that will produce what we want in terms of new insights in science, engineering, and medicine, but will not also allow people to do catastrophic things with it. Things out of their naivety, things out of their malign intent, things out of their overconfidence, things out of malice, either their individual malice or collective malice. And indeed, how do we prevent the AI itself from doing things out of its own deliberations after it decides that humanity, even enhanced humans, is an irrelevance on the grand cosmic scale of things? In this presentation, I'm going to look at three different approaches to trying to successfully build beneficial general intelligence. And as well as these three general approaches, I'm going to look at three critical problems which all of us need to face in this task. The three approaches are distinguished by how much we try to put in to the beneficial general intelligence. The first approach might be called as it comes. People keep on adding in more intelligence, more deep intelligence, more general intelligence, and whatever comes out, people hope will be beneficial. The second approach is to say, well, that's not quite right. We have to make more efforts to add in extra features. Features perhaps such as wisdom or compassion or benevolence. A third approach is to say it's not what we add in that's important, it's what we leave out. Therefore, the priority is to remove various features in what we might call AGI minus. Leave out any tendency to become sentient, or for autonomy, or for volition, free will, or agency. So that's the choices facing us. Now for the problems. The first problem is that before we get to the kinds of artificial general intelligence we have in mind, whether it's AGI or as I've called it, AGI plus or AGI minus, we will inevitably have systems that aren't quite right. They are in various ways immature. Version 0.1, version 1, version 1.5, not quite at the intended level. Inevitably, there will be bugs. So we might think we have got an artificial intelligence that can correctly calculate things to do with the environment and climate change, or things like how to build a safe nuclear reactor, or how to deal with some human biological issues, and it may get it wrong in this immature state. Likewise, when we are trying to create an AGI that doesn't have agency, we might slip up in these early phases, and the AGI might develop volition, free will, despite our intentions and despite what our completed product might have. And likewise, before reaching AGI plus, we might have a buggy version of the system that calculates what's benevolent and what's not. And it might reach decisions very different from the ones which we hope to train into the final version. So that's the first problem. The second problem is, well, if we do manage to build what we have in mind, what's going to happen when that system self-improves beyond its initial state, taking advantage of its desire, its inherent desire to improve its ability to do whatever its goals are. So we might go beyond the first AGI to reach what people sometimes call artificial superintelligence, in which that system isn't just able to outperform any individual human in all aspects of rational thinking, it's able to outperform all of humanity. Likewise, we can look to what goes beyond AGI plus. Perhaps we might call that a SI plus, in which it has very different views as to morality and ethics than the ones that it started off with. Just as we humans have evolved our views on ethics and morality as we have gone through the centuries. In principle, there is an ASI minus as well, self-improve from the AGI minus, though if we get the programming of AGI minus right, it won't have any inherent tendency to self-improve. We might come back to that later. So here's another diagram to look at this second problem, the problem of self-improvement. In this diagram, not to scale, of course. The scale is completely unknown. I'm listing all forms of AI, including a section which is for this potentially catastrophic AI, PSI, and a subset of that for what I sometimes call FUI, that's the potentially humanity usurping AI. We don't want either of these. We want this science, engineering, and medicine transforming AI, SEMTI. And to be specific, we want something here that's not in the other circles. That's the most desirable form of AI. But to be clear, we want to ensure that it won't self-improve into these areas, which would be terribly dangerous for humanity. This is not just an abstract academic discussion. There are various groups who might be positioned in various columns here. For example, Craig Mundie, the former head of research in Microsoft, has spoken eloquently of his vision that AIs will be controlled by an adjudication layer specially built, somewhat similar to the constitution layer inside some of Anthropic's AI systems, and this adjudication layer will be specially trained on all the world's greatest wisdom. Similar remarks are made by many in the extended singularity net community. On the other hand, there are people such as Max Tegmark of the Future of Life Institute who say, no, we should not be building general intelligence with full autonomy. We should be building what he calls tool AI, or what Yoshua Bengio, the world's most cited computer scientist, has described as scientist AI, without the volition. So there are different approaches to be taken. And as I've said, there are three problems, three critical problems we need to face. I've talked about the first. The initial systems will have bugs and immaturity, which may catch us out before we get to the systems we have in mind. I've also talked about the potential for these systems to self-improve in dangerous ways. But the third, and perhaps the most troubling problem of all, is that whilst we may have our own plans on what we are convinced will be a safe BGI, other groups around the world are probably pursuing different approaches to build AGI, which will result in dangerously risky versions. So we have the global coordination problem. This cannot be solved by individual groups. It will require we humans to talk to each other in ever more intelligent ways. Now, one approach to this problem, when it is pointed out, is people say, yes, I take the point. These other guys over there may well create something which is dangerous. It doesn't have the right incentives. It doesn't have sufficient benevolence built into it or whatever. But we are going to be there first. We are going to double down, put our foot to the throttle, to the floor, and ensure that we get to BGI before any of these unsafe versions get there. So there is a race. That's not what I advocate at all. I believe that in such a race, safety principles will inevitably be elbowed aside. Instead, a far better approach is to establish a global consensus, which has various parts to it, a global consensus that racing to build a BGI is deeply risky, that there should be reliable global monitoring of large-scale compute, backed up by sanctions and other mechanisms to deal with groups that fail to respect and apply these safety standards. And if this global coordination could include the countries in the G7 and their allies, and China, and a few others, I think that would be sufficient. But it's not just the global consensus is talking about dangers and sanctions, it will also offer a carrot alongside the stick. It will point out that if these principles are followed, everyone will marvelously benefit from the very rich BGI that is obtained, or to use a word from one of the tag phrases of the BGI summit, which will be taking place toward the end of May in Istanbul, Turkey. This will be a compassionate and abundant future. Thank you very much.